All right, welcome back. Today we're doing something pretty cool. We're going to peek inside the mind of some really advanced AI. I mean, we're not just talking about what these AIs decide, we're going to dig into how they actually come up with those decisions. So let's just jump right in.
So let me just throw this out there. Imagine an AI that can look at a photo of a patient's face, scan a few clinical notes, and then boom, diagnose a super rare genetic syndrome. Sounds like sci-fi, right? Well, it's not. The answer is yes, it can actually do that. But that brings up a way more important question, doesn't it? How on earth are we supposed to trust something like that?
So the magic behind this is something called multimodal AI. And really, all that means is that these AI models are no longer just one-trick ponies. They can process and connect information from totally different sources at the same time. Think about it. They can see an image and read text and then blend that understanding together to make one single really smart decision.
And look, on one side, this is just incredible, right? The AI can analyze medical photos, read doctor's notes, and predict diseases. And it's often shockingly accurate. But, and this is a huge but, we run smack into the classic black box problem. We put the data in, we get an answer out, but what happens in between? It's a total mystery. We have no idea how it decided that this part of a photo connects to that word in the notes. And when you're talking about someone's health, that's not just a puzzle, it's a massive risk. You can't trust what you can't understand.
Okay, so if we're ever going to use these amazing tools safely, we absolutely have to find a way to crack that box open. And that's exactly where this new framework called MultiSHAP enters the picture.
Now, people have tried to explain AI decisions before, of course. But the old methods kind of fell short. Some were good with text, others were good with images, but they were pretty clumsy when it came to explaining how the two worked together. And a lot of them required you to have the AI source code, which isn't always possible. MultiSHAP is different. It was built from the ground up specifically for this multimodal world. It can work with pretty much any model out there, and the level of detail it gives us, it's just on another level.
So let's break down why this is such a game changer. First off, it's model agnostic. That's a fancy way of saying it doesn't care what kind of AI it's looking at. It doesn't need the secret recipe, the internal code. It can explain even closed-source black box models just by poking them with inputs and seeing what outputs they spit out. Second, it's fine-grained. This is so cool. It's not just going to say, oh, the photo was important. No, it'll tell you this specific patch of pixels over here, the one showing an eyebrow, had a huge interaction with this specific word in the doctor's notes. And finally, it's cross-modal. That's its whole reason for being, to find and explain those hidden connections between what the AI sees and what it reads.
So how does it actually do all that? Well, MultiSHAP boils it all down to two key ideas that it measures between the image and the text. It's looking for either synergy or suppression. Let's dig into what those really mean.
First up, we've got synergy. This is the good stuff. It's when a feature in the image and a word in the text basically team up. They amplify each other, making the final conclusion even stronger. Their combined power is way more than what they could do on their own. It's that classic 1 + 1 = 3 effect. Think of it like two detectives who both find a clue, and when they put them together, the case is solved beyond a shadow of a doubt. And then you have the total opposite, suppression. This is what happens when an image feature and a text word just don't get along. They conflict, they contradict each other, and they actually weaken the AI's confidence. They kind of cancel each other out, so it's more like 1 + 1 = 0.5. Now, sometimes this is a good thing. The AI might be correctly ignoring a misleading piece of information. But as we're about to see, this can also be the very thing that causes the AI to make a huge mistake.
All right, enough with the theory. Theory is one thing, but seeing is believing, right? Let's dive back into that medical case study and see what synergy and suppression look like in the real world. This is where it gets really interesting.
Okay, so here's the setup. We've got a rare genetic disorder called Cornelia de Long syndrome, or CDLS for short. It has some very specific facial tells. The AI gets just two things: a photo of a patient's face and a very simple question. What's the most likely diagnosis?
First, let's look at a time when the AI absolutely nails it. And, surprise, surprise, it all comes down to those powerful, synergistic interactions.
So in this case, the AI correctly identifies CDLS. Perfect. But how? Well, we run MultiSHAP, and what we see is a heat map that's just glowing with red boxes. That red means strong synergy. The AI is making these super strong connections between the question it was asked and the really important visual clues, the eyebrows, the shape of the nose, the philtrum. The synergy ratio is high, which basically confirms, yep, all the clues were working together, and that's why it got the right answer.
But what about when the AI fails? What happens then? Well, more often than not, the villain of the story is suppression.
Okay, get this. Here's a misdiagnosis. The AI looks at a patient who does have CDLS, but it predicts something else entirely. MultiSHAP shows us exactly why. The heat map is now covered in these blue boxes, showing strong suppression right over critical facial features, like the eyes and the mouth. The AI is literally downplaying or even ignoring the most important evidence. And the low synergy ratio tells the tale. This internal conflict, this suppression, is what sent the AI's reasoning off the rails and led to a really dangerous mistake.
And that right there, that ability to perform an autopsy on an AI's mistake is why this is all so incredibly important. This is about building a future where we can actually truly trust these systems.
So why does this matter so much? Because for the first time, we can see exactly where and why an AI went wrong. We can diagnose its failures. This means we can go in and fix the model's weaknesses. And crucially, it means we can start building real, evidence-based trust in using AI for things that really matter, like medicine. We're finally taking that opaque, scary black box and turning it into a transparent glass box that we can actually look inside.
Which really leaves us with one last big question to think about. Now that we have tools like MultiSHAP that are starting to crack open that black box, it really makes you wonder, doesn't it? How much should we ever have trusted in AI that we couldn't understand to begin with? Something to chew on. Thanks for joining me.